Hi there, and welcome to our third lesson on rational expressions. Today we're going to be doing adding and subtracting, and in order to help us with that, I want to take a look at what we do with regular fractions and pull from that things that will be helpful when we're dealing with rational expressions. So here I've got 2/8 plus 3/4, and we know that when we add or subtract fractions, the first thing we need to do is get ourselves to common denominators, and that's pretty easy with this one. Because we know that we can simplify that 2/8 to be 1 over 4 plus 3 over 4. Once we have the common denominators, we know that we add the numerators, put it over top of our common denominator, and that gets us a fraction that we can reduce or simplify with our addition. So when we have things that are a bit more complex, I want you to think of the common factors in terms of writing our denominators out as a product of its prime factors. So here we go. I'm going to show you what I mean by that. If I have 3 over 14 plus 5 over 6, I know that 14 written out as a product of its prime factors would be 2 times 7, and 6 as a product of its prime factors would be 2 times 3. So I'm going to rewrite these fractions with that as the denominator, and 5 over 2 times 3. Now, when I have it written out in this form, I can see what's common between the two, and that's the number 2, and I can see what's missing between them. And using that information, I can see that the fraction on the left, I'll have to multiply the top and bottom by 3, and the fraction on the right, I'll have to multiply the top and bottom by 7, if I'm going to convert these over to equivalent fractions. So let's go ahead and do that. I'm going to multiply the top and bottom by 3, and I'm going to multiply the top and bottom by 7, and I get 9 over 3 times 2 times 7 is 42, and that's 35, and 2 times 3 times 7 is 42, and that gives me the ability then to add the numerators together over our common denominator, and I get 44 over 42, which equals 1 and 2 42nds. Oops, I could simplify that, couldn't I? 1 and 1/21. So writing the denominator out in terms of its prime factors, it's a nice concept that will help us with the rational expressions. It makes it easy to see what's common between the two denominators, and it makes it easy to see what's missing between the two denominators. So let's take that concept and apply it to a rational expression with a fairly easy monomial in each denominator. If I write this back out with the denominators as a product of its prime factors, I see that what's missing is a b. And so in order to convert the right-hand fraction into a common denominator, I have to multiply the top and bottom by b. Oops, sorry. And then I can get 4 over a times b plus 5b over a times b. That equals 4 plus 5b over, that should be a b, over ab. Typically I would write the variables first, so I could write that as 5b plus 4 over ab. And that is the rational expression that I would have as the answer. There's no way that I can simplify that, so that is as far as I can get. Let's take it one that's a little bit more complicated. Here I've got 6 over, I can go 2 times g times h. That's the denominator written out as a product of its factors. The denominator here would be 2 times g times h times h times h. And I can say that a 2 is common, a g is common, and an h is common, which means on the left-hand side, I need to multiply it by h squared. And on the right-hand side, I need to multiply it by 2g. Right? So there's the h squared that's missing, and there's the 2g. So let's write this out. I've got 6 over I'm going to write this back as its proper denominators just for ease of use. So I'm going to multiply the left-hand side. We said I was multiplying the left-hand side by h squared over h squared, and the right-hand side we're multiplying by 2g. So that gives us a common denominator of 4g squared h cubed, right? So that multiplies onto that, gives me 4g squared h cubed. This multiplies onto that, gives me 4g squared h cubed. In the numerator here, I've got 6h squared, plus here I've got 4g squared. Now, I can simplify a little bit here, and in order to do that, I'm going to factor this top, and I can factor out a 2 and be left with 3h squared plus 2g squared. And in the denominator, because I've got a 4, that 2 can cancel into that 4 and leave me with 2. So my final answer is 3h squared plus 2g squared all over g squared, 2g squared h cubed. So that's a bit of a longer process. The concept still applies. I'm taking a look at my denominators, seeing what's common and what's missing, multiplying by the missing elements so I can create an equivalent denominator for the two fractions. Then I'm examining what happens in my numerator and seeing if there's any way that I can simplify. And by simplifying, basically I'm reducing that rational expression to its simplest terms. Is there anything else that I can do in this rational expression? No. There's nothing I can factor in the numerator, and I can't cancel the g's or the h's in the denominator into the numerator because I have to treat this thing as one piece up here. Alright, so let's take a look at a couple of other examples here, see if we can keep on going. I'm going to see that on the left-hand side here, what I'm missing is an n, so I'm going to multiply the top and bottom by n. 2m plus 4n over 30mn. So this is a pretty easy job for converting to equivalent denominators. That would give me 6n plus 2m plus 4n over 30mn. But I want you to take a look at what happens in the numerator now, because I'm now in a situation where I have some like terms. So that's another thing that you have to consider. There might be some like terms that you need to combine. So this will end up being 2m plus 10n over 30mn. Now I can look at reducing my fraction, or simplifying it, and I can say, oh look, I can pull a 2 out of here and be left with m plus 5n over 30mn, and that 2 will go into the 30 and leave me with 15. So my final answer becomes m plus 5n over 15mn. And again, there's nothing that I can cancel here. I need to treat that numerator as one piece, so I can't cancel the m's or the n's. Now, is there any difference when we are subtracting? In fractions, when we're using fractions, there's no difference. I have to find equivalent fractions with a common denominator, and then I subtract the numerators. So let's do this example here. This would be a plus b over 3ab. Write it out as a product of its factors if that helps you. 3a plus, 3a plus b, my goodness, 3a plus b over 18ab. And to get the left-hand side to be an equivalent fraction, I have to multiply by 6. So I get 6 onto a plus b over 18ab minus 3a plus b over 18ab. This distributes in, 6a plus 6b minus 3a minus b. Why do I keep writing 5s for my b's? Notice that when I'm subtracting this binomial, that's like an implied 1 here, so I need to distribute that subtraction sign on, which will change this to a minus, and change this to a minus. All over 18ab. Now I can combine some like terms. I've got 6a minus 3a gives me 3a. 6b minus b gives me a plus 5b, all over 18ab. Is there any factoring I can do to simplify this rational expression? No, at this point there isn't. The numerator cannot be factored, neither can the denominator. So that's my final answer. Now, all those examples that we've been looking at have had monomials in the numerator and the denominator. What if there was some binomials or trinomials? Well, I take a look at this and I rely on some of the work that we did with our factoring unit, and I get in the denominators here, I'm going to do some factoring, and I get this trinomial, g squared minus 3g plus 2, factoring down to minus 2 and minus 1. And over here, I get this guy. I can factor out a 2, get g minus 2. And now that I've got it written out as a product of its factors, I can see that there's a g minus 2 in common, which means the left-hand side needs to be multiplied by 2, and the right-hand side needs to be multiplied by g minus 1 over g minus 1. So this is exactly the same idea that I was doing up here in these examples, where I would multiply a side by a monomial like I did here, except instead of a monomial, it's more complex now, and I'm multiplying by binomials. Okay, so let's do this multiplication. This is 2 onto 5g plus 1, minus 1, plus 3 onto g minus 1. All of that is going to be over my new common denominator, which I'm going to leave in this factored form so I can do some reducing later, hopefully. I distribute, which gives me 10g minus 2 plus 3g minus 3, all over 2g minus 2, g minus 1. And then I can do some combining of like terms. And I can get 10g plus 3g is 13g, minus 2 minus 3 is minus 5, all over 2g minus 2, g minus 1. Now I can look at this and say, is there any factoring I can do further here? The answer is no. Is there any simplifying I can do here? And again, the answer is no, so that would be my final answer. So that's the lesson. Sorry, I thought there was one more example, but there's not. So please take notes, ask questions if you have them, and we'll see you in class.